Printers do not just randomly break down. They are highly evolved machines that actively feed on your suffering. You know that feeling when the office printer jams on your most important document? We treat these beige plastic boxes like enemies, but they are actually engineering marvels. Chester Carlson invented this core process to transform digital data into a physical object. It is not just stamping ink onto paper. It is a microscopic electrostatic symphony. Let us look inside. The heart of the machine is the photoreceptor drum unit. A primary charge roller applies a uniform, high-voltage, static electrical charge across its surface. Think of it like rubbing a balloon on your hair, but perfectly, highly controlled. The entire cylinder becomes a blank canvas of negative static electricity, waiting for instructions. This is where the laser comes in. It does not burn the image directly. Instead, a precision laser beam rapidly scans across the spinning drum's highly sensitive surface. Wherever the light hits, it neutralizes the static charge in that exact microscopic spot. This creates an invisible electrostatic blueprint of your document on the green metal cylinder. But how do we make an invisible static charge visible? We need the toner. Toner is not liquid ink. It is actually a fine powder made of plastic. These microscopic plastic particles are mixed with iron oxide, making them sensitive to magnetism. The toner gets its own electrical charge through friction, called triboelectrification, as it stirs. Because opposites attract, the charged plastic dust leaps onto the discharged, laser-drawn blueprint. Now, the printer feeds a sheet of paper into the machine from the tray. The paper passes over a transfer roller, receiving a much stronger positive electrical charge. This massive charge literally rips the plastic powder off the drum onto the paper. But the plastic dust is just sitting loosely on the surface, easily blown away. If you touch it now, the document would instantly smear into a messy cloud. To make it permanent, the paper enters the thermodynamics phase in the fusor unit. Two heavy metallic rollers apply immense pressure and extreme heat to the fragile page. The temperature reaches over 400 degrees Fahrenheit, hot enough to cause severe burns. This heat flash melts the plastic microparticles, fusing them permanently into the microscopic paper fibers. That is exactly why your printed documents always feel so wonderfully warm upon exiting. Finally, a rubber cleaning blade scrapes any leftover plastic dust off the spinning drum. A discharge lamp erases the remaining electrostatic blueprint, preparing for the next continuous rotation. All of this extreme physics and thermodynamics happens in just a few short seconds. It requires absolute mechanical precision, which is why a single crumpled corner ruins everything. Yet, despite the constant paper jams and the blinking red lights of total failure, the laser printer remains one of the most complex devices in the modern office. It harnesses static electricity, lasers, and flash-melted plastic just to print a simple memo. So the next time your printer flashes a cryptic error code and stops working, try to respect the microscopic engineering and the melted plastic happening right inside it. It is doing its absolute best in a world of cheap paper and dust. Even if it seems like it hates you, it is just following the physics. Tell me, what is your absolute worst, most frustrating printer jam experience at work? Share your mechanical tragedies below, and remember to always check the paper tray first.